Welcome to the NExT Forum, Next Generation Communication for B5G and 6G. My name is Taipei Kuo. I'm the advisor of Honghai Research Institute. There are many cyber-physical systems emerging over the horizons. Networking and communication is not only a must, but also a driver to the future society. There are many driving applications, such as multisensory, augmented reality applications, virtual reality applications, and even mixed reality applications. We are going to see a lot of connected robotics and autonomous systems in the fields, such as auto-driving vehicles. We are going to have a lot of advanced human-computer interfaces being used in different systems. For all the emerging cyber-physical systems, we need advanced next-generation communications. We are going to need more bandwidth and more spectrums. The communication networks must be reliable than ever. They must be very energy efficient. We are going to have integrated terrestrial, airborne, and satellite networks. We are going to cover most of the space on Earth. We are going to have convergence of communication, sensing, control, localization, and computing. For many systems, we are going to have machine talking to machine. There are going to be a massive amount of data floating over the networks. To process all the data, we probably cannot send all the data back to the cloud because we have some latency requirements. So most of the time, we have to rely on edge intelligence. We probably also need some openness in protocols and interface designs to drive the innovation. One question we want to ask ourselves is whether the artificial intelligence solution can be scalable to existing platforms. Think about the needs that we need to process so much data on end devices, such as vehicles. We might also send or process the data over the clouds. A lot of data have to transmit it from end devices to the clouds and compute for certain purposes. We might have trouble to load all the data from the storage to memory for processing, or even to the CPU, GPU, or AI chip for processing. How can we do that? Can we conquer the needs of latency requirement in certain systems, such as manufacturing? There are a lot of challenges. Think about edge intelligence. We want to provide artificial intelligence over edge. Think about massive data generated at the end devices and edges. We actually need artificial intelligence to unlock their potentials. We need edge computing because it provides promising solutions to meet the demands in low latency, energy efficiency, and also privacy protections. There are many applications, such as Industry Internet of Things, autonomous driving. Let's take autonomous driving as an example. We should consider perception, localization, planning, and control. There are a lot of vehicles that are running over the fields. We have to detect and locate the nearby objects based on image data and point cloud data. We need to locate the vehicle in space by using GPS, high-definition map, and IMU. We have to do planning, locally or globally. We have to decide the routing from the user-defined destinations. We also need to generate collision-free paths from current position to the immediate goal position. Those computing may be done on edge devices or your end devices, and even over your cloud. Remember that we have a lot of data being transferred over the networks. So we have to build the entire structure and system. The end device or the system have to output steering, throttle, brake, and gear commands to precisely follow the planned path. Well, you're going to see lots of data and lots of computing over devices, edges, and cloud. We can look at this entire system from the user, vehicle, roadside unit, or to the government perspectives. Well, a lot of data have to display on panels. How about display personalization? So much information need to be displayed. What would be best to the drivers? Think about multiple vehicles. Then you have to think about cooperative driving and even platooning. Those data probably being packed or processed on your networks, edges, devices, or even your end devices. If you have multiple cameras inside the same city or even across cities, you probably need data fusion. They might happen in the clouds or over your edge devices. When you think about path planning, well, as I mentioned, they can be global or local. Of course, you think about edge computing or computing over the clouds. If you think about traffic efficiency, well, of course, there are lots of data being transferred over the networks or processed in the cloud. We probably need digital twin for not just simulation, but also control and management. We probably need accident liability assessment as well. So there are a lot of challenges in infrastructures, in communication and system design. For example, our communication network must be reliable. We must meet the latency demands of different applications. There are lots of data being transferred over the system. We have to process those data over multiple system tiers. Another interesting driving application is from the smart industry. We see the convergence of artificial intelligence and Internet of Things. You will notice that networking and communication is the must. Those Internet of Things are connected, obviously. They can improve the operation efficiency. They can be deployed for different fields such as agriculture, transportation, healthcare, and also manufacturing. The entire market is expected to grow from $76.7 billion in 2021 to $106 billion by 2026 at a compound annual growth rate of 6.7%. We can build smart industry. We can have light of factory with full automation. With all the operation efficiency, we can expand the territories. Think about smart manufacturing. We can build and manufacture after demand or orders. We can actually build a system with zero stocks. Of course, as I mentioned in the beginning, openness can bring innovation. We can have something like Open RAN. It can be empowered by principles of intelligence and openness. We can build virtualized RAM with open hardware and cloud with embedded AI-powered radio control. We can have openness in protocols and interface designs. We can leverage AI in layers of RAN architecture. Well, the innovation might come with some cost. For example, interoperability, reliability, and some optimization issues. We need the next generation operation for the networking and communications. Of course, we see lots of potential driving applications. We also see the trends. With so many data being transferred over the networks, we need the system and communication to be energy efficient. We are going to have integrated terrestrial, airborne, and satellite networks. Data will be processed and transferred over the networks. To realize the next generation application and also communications, we need enabling technologies. Thank you for coming to the forum. In the forum, we invited many respected speakers in different fields to share their thoughts and design ideas. I hope you enjoy the forum. Thank you very much.